So I'm going to solve this. In order to solve this equation, first step is to get rid of that 2 by dividing both sides by 2. So once I divide by 2 there, I get e to the x minus 2 equals 10. Next step is I want to solve for x, but my x is in the exponent. So in order to get that out of the exponent, I need to use logarithms. So I'm going to do log base e, because the base of the exponent is e. I'm going to switch these two. So it's going to be log base e 10 is equal to x minus 2. I just converted the blue into a log. Now can we get rid of this and we have x equals? How do we get rid of that? We are going to add 2 to both sides. Now, watch carefully. It's a little bit weird. We get, oops, let's switch that to cross those out. X equals 2 plus ln 10. Because log base E10 is ln 10, and I put the 2 in front because if you put it behind, you're going to make that a 12, possibly, and you don't want to do that. So that's ln 10 plus 2, or 2 plus ln 10 is x. And this is your answer. If you had a calculator, could you crunch this? Yes, it's a decimal. Could you plug this in and check? It's kind of hard. We're not going to worry about checking. You just better have done it right. It's kind of hard to check. So next one, let's read this. How much of an initial investment would you need for it to be worth at least $4,500 if it is compounded yearly at 7% over 11 years? Create an inequality, but do not solve it. That could be used to find the initial investment. Let me highlight some keywords here. First keyword is at least. That's really important. We're also going to be inequalities. Kind of important here because there's no equal sign on this final answer. So that at least will show up to be very important. To do these problems, first step is we've got to think of what function is this. And we have to think what type of equation. And hopefully you understand for this one, your type of equation is going to be a equals p 1 plus or minus r to the t. That's the type of equation we're going to be using. So we have to look through this problem to figure out what's a, what's p, what's r, and what's t. So let's put this together. Do we know what a is? What is a? Does any of this stuff talk about the final amount? And yes, it does, right there. That right there is a final amount. So I know a is 4,500 equals. Do we know p? Do we know the principal, the initial amount? No, that is what they're asking for. The principal initial amount is what the question's asking for us to figure out. So we don't know p, so we're going to put p there. We know that 1. Is this growing or shrinking? Well, if it's an investment, it's most likely growing. It doesn't say it exactly, but let's assume it's growing. So that's going to be a plus. My rate, well, what is my rate? 7%. So 7% in terms of decimals, 7% is like 7 cents. So let's write 7% as a decimal, which would look like a 7 cents. So that's what it should look like. Lastly is t. So t, okay, do we know a time? Yes, 11 years. So we plug in 11 right there. Okay, so we wrote an equation. Doesn't it say an inequality? So I need to convert this now into an inequality, and I have the word at least. To do an inequality, I'm going to do a little flipping here. I'm going to rewrite this as p 1.07 to the 11th and 4,500. I did a little flip here because for having an inequality, I think it's easier to read if the inequalities starting with this and leads to the 4,500. I think it's just easier that way. But we have to read at least 4,500. At least means that's the lowest it could be, so we're looking for something above that. If we're looking for something above something, that means we're looking for something greater than or equal to that something. So that is the inequality. Because we're looking for something at least 4,500, meaning we're looking for something above or equal to 4,500. If you were to write it in this format, it'd be a less than or equal to. I think it's a little bit more confusing. It's easier to write it in this form. This last problem here. There are 5,000 fish in a pond. The population is decreasing. Let me underline that word, decreasing. It's going to be really important. And this word, continuous. Both those are very important. So we have 5,000 fish decreasing continuously at 15%. We want an inequality again, and but do not solve it. It could be used to find out until there are at most 30 fish. That at most is going to be important. So at most is going to be very important. So we are shrinking continuously, and it's going to be at most 30. So this word continuous means we're not going to use this format. Continuous means we are going to be using the formula A equals P e to the RT. It's a continuously compounding event, so we're going to use the E number. E is a number. It's not a variable. So let's read this carefully and plug things where they belong and go from there. So A, do we know our final amount? Yes, our final amount is 30. So I'll start with 30. Because 30 is what we're going to get to. We're actually looking at most 30. We'll come back to that. Do we know our P, our initial amount? Yes, there's 5,000 fish in the pond. Man, the pond sure is shrinking from 5,000 to 30. We have E and the R. Do we know the rate? Yes, the rate is 15%, but it's negative. Isn't it decaying by 15%? And do we know T, the amount of time? No, that's what we're looking for. So let's make our variable T. So we just made an equation that is continuously decaying at 15%. But I want an inequality that ends with an at most 30. So let's rewrite this so it's an inequality at most 30. So I'm going to start with 5,000 e to the negative 0.15 t, and I'm going to go 30. So I like to rewrite it again. And I'm saying at most 30, isn't it the highest it could be is 30? So don't I want underneath that? The highest is 30, I want underneath that. Underneath that's a less than. So I'm going to call this less than or equal to 30. I want to know when it goes below 30 fish or equal to 30 fish. And that right there is an inequality for this particular problem.